On July 23, 2024, Europe's Solar Orbiter spacecraft observed a powerful solar flare erupting from the far side of the Sun. While this flare wasn't the most extreme ever recorded, we were incredibly fortunate that its effects did not reach Earth. Solar flares often lead to long-lasting radiation storms, and if one of these storms heads toward Earth, it can result in worldwide blackouts. Before diving into the details of this potentially catastrophic solar flare, let's first understand what a solar flare is. These flares occur because the Sun's magnetic fields are constantly in motion. As the Sun approaches its solar maximum, the most active period in its 11-year cycle, which is happening right now, these magnetic fields become increasingly tangled, resembling an enormous ball of intertwined rubber bands. These magnetic fields twist, cross over each other, and sometimes disconnect, causing hot plasma on the Sun's surface to accelerate, releasing powerful radiation into space. This is a solar flare. In other instances, the Sun ejects massive amounts of material, known as coronal mass ejections, CMS. A single CME can contain up to 20 billion tons of matter and travel at speeds exceeding 1,000,000 miles per hour. Both solar flares and CMS are the most powerful explosions in our solar system, unleashing vast amounts of energy. Solar flares are classified based on their strength. The weakest are A and B class flares, -1 by C, and M class flares, with X class flares being the most powerful. The X class scale can go higher than 9, similar to how the Richter scale works for earthquakes. Now, back to the recent solar flare, classified as X 1.4, meaning it was particularly strong. The July X class flare, though not Earth-directed, could have caused significant disruptions if it had. Such a solar storm could have triggered impressive auroras, but also serious technological problems and electrical blackouts, similar to the event in 1989 that damaged Quebec's power grid. This flare, however, wasn't as powerful as the famous Carrington Event in 1859, which is the strongest solar storm ever documented. A flare in August 1972 even destroyed long-distance telephone lines, forcing redesigns of power systems. In 1989, a major CMS triggered a geomagnetic storm, causing a blackout in Canada that affected 6 million people. These events pale in comparison to the Carrington Event, but they still highlight the potential damage solar flares can cause. More recently, in December 2006, another X9 class flare caused significant disruptions in satellite communication. In February 2022, SpaceX experienced the effects of a geomagnetic storm that destroyed 38 newly deployed Starlink satellites. These satellites, vulnerable due to their low orbits, were unable to overcome the increased atmospheric drag caused by the storm and ultimately burned up in the atmosphere. Though we avoided catastrophe this time, solar flares remain a potent threat to Earth's technology and infrastructure. Stay tuned with the Daily